Welcome to A-Level and AP Physics, a place where you can improve your understanding of physics with confidence. In today's lesson, we will talk about capacitors and capacitance from Cambridge A2 Physics. In this class, we will only focus on past paper questions, and today's question is from May-June 2016, question number 7. This question is about experiment. With the help of this experiment, a student wanted to measure the charge on a capacitor for different values of potential difference across the capacitor. Experimental setup is given to us. As you can see here, voltmeter is connected across power supply, and this is variable power supply. Capacitor is also given to us. A switch is connected here, and a meter is used to measure the charge on capacitor. Student did this experiment and then he plotted data points. He took potential difference on x-axis and charge on y-axis. Data points are given to us. As you can see here, these red dots are data points, and 5 data points are given to us. What we need to find out, simply we need to state and explain that there is a systematic error in the readings of one of the meters. So how we can answer this one? Let me explain to you first of all what is systematic error. So systematic error is the key thing we need to understand. If we don't understand systematic error, then it is difficult to answer this question. Systematic error, first of all, we need to understand what exactly is systematic error. Systematic error simply means that our measurements will be greater than or smaller than actual value. For example, if we have value of G that is equal to 9.81 meters per second, and this is the actual value. If we got measurements like this, let's say we got measurement 9.2, then we got 9.1, again we got 9.3, and let's say we got 9.0. As you can see here, these values are very close to each other. We can say these values are precise, but they're not accurate because these values are just lying on one side of actual value. They're smaller than actual value. This is also true if we got all the values greater than actual value. So it means there is systematic error in the readings. So this is one thing. So how we can answer this one now? How we can answer this question? So to answer this question, we need to understand Q is equal to CV. This one is telling us when the potential difference across plates of capacitor is equal to 0, the charge on capacitor has to be equal to 0. And vice versa is also true. When there is no charge on the plate of capacitor, means there is no net charge on each plate of the capacitor, there will be no potential difference across capacitor. So if there is systematic error in this case, so how we can see with the help of graph? So as it is given to us, Q is on y-axis and the potential difference on x-axis. If there is systematic error in Q, our graph will look like this. And if there is systematic error in V, potential difference, our graph will look like this. Now, as these data points are given to us, we just need to draw the best fit line, and then we can see the systematic error. Is the systematic error is in potential difference, or systematic error is in charge? So first of all, let's try to draw the best fit line. So here is how we have drawn the best fit line. You can see here. So in this case, you can see when the Q is equal to 0, at this point Q is equal to 0, but the V is not equal to 0. It means that there is systematic error in potential difference because the graph is, this line is not passing through origin. So this is our reasoning, and this is what we have found, the systematic error. Now let me explain to you how to write a proper answer for this question. So here is our final answer. This is how you can write down your final answer. So you can see here, the first thing we said, when the potential is 0, the charge store has to be 0, but it is not 0. It means there is systematic error. So if you write this one, you will get 1 mark. And the second, we have to explain now, because it has to be a straight line. It has to be a straight line if there is no systematic error, and it has to pass through origin, but in this case it is not passing through the origin, so that reason there is systematic error. If you write this point, you will get the second mark. So this is how we can answer. I hope it is quite clear to you. Let's move on to part B now. For part B, what we need to find, simply we need to determine the capacitance in microfarad of capacitor C. We need to determine the capacitance. So how we can determine the capacitance if the graph is given to us like this? So again, we need to understand that Q is equal to CV. And this is true when there is no systematic error. So we can also write down this one, that y will be equal to mx. This is straight line equation. But now, as you can see here, there is a systematic error. I can simply say this is systematic error. Now, in this case, for example, the Q is on y-axis, and you can see the capacitance in this case will be equal to the gradient of the graph if we have Q on y-axis and we have potential difference on x-axis. And this is the case. As you can see, on y-axis we have Q, and on x-axis we have potential difference. So what we need to do, we simply need to find the gradient. So if we find the gradient of this line, the gradient will be equal to capacitance. So simply we need to find the gradient that will be equal to capacitance. So I have already calculated this one for you. So I will just show you my answer, and then we move to next part. There is nothing more to explain. So here, this is our final answer. So as I have calculated, I got this answer. This answer has 4 significant figures. We can reduce this one to 2 significant figures. If we reduce to 2 significant figures, we can write down this answer. So this is our final answer. Let's move on to next question now, the part C. Next one is part C. For part C, we need to determine the additional energy stored in the capacitor when the potential difference is increased from 6 volts to 9 volts. So now we need to understand how to calculate energy store, in a capacitor. So energy store in a capacitor, we simply calculate that E is equal to 1/2 CV square. As the potential difference is given, and C we have already calculated. Let's say this is energy E1, and here let's say is E2. So we will say V1 when the potential difference is 6 volts across capacitor, how much energy is stored in the capacitor. And when the potential difference across capacitor is equal to 9 volts, how much energy is stored in the capacitor. So we can find E1, we can find E2. So I will say this is V1, and here we can find 1/2 CV2 square. This is. Now we need to find the increase in energy, means the additional energy if the potential difference increase from 6 to 9. So simply it means we need to find the difference between these two. We can simply say E2 minus E1. So as you can see here, 1/2 CV2 square minus 1/2 CV1 square. So what is common here in this case, if we look at this, 1/2 C is common. Here this is common, so we can take this out. So 1 half C. So inside we left with V2 square minus V1 square. And then we just need to plug in values. We have value of capacitance from here, and value of V1 is 6 volts and value of V2 is 9 volts. And we just need to plug in values and we will find the additional energy stored in the capacitor. If we increase potential difference from 6 volts to 9 volts. So this is the main process, and if we follow this one we will get our correct answer. But most of the time smart student, they often do like that, but that is not a correct way. They will say, oh, 1 half C and delta V square, but delta V you will get wrong answer. So please don't be too smart, don't do like this. You have to follow this. So let's go and do our calculations and finish this question. So here is our final answer. Let me make little more space so you can also see here what I have written here for you. I have explained to you how to do this question, and here just calculations. So this is our final answer. It has two significant figures, 2SF. That's all for this question.